This is question number 6. It has a point value of 2 points. This is for countercurrent exchange, which is a process of running fluids in opposite directions in order to maximize the exchange between them. So what we're looking at here is a loop of Henle. So pretty much how it works is your filtrate will flow down through here, loops back around, and on this side salt will actually permeate inward through here, and what it does is it increases the concentration of salt in the center area. Water in the filtrate can't flow through the right side of the loop, so it just goes out. On the left side though, the water can flow in, so water will flow in this side, and it tries to balance out the concentration here, while the rest of the salt in that solution will flow down and around, and it will actually get pulled into the center too. So it's constantly pulling water out here, and salt's constantly being put in here, and it's trying to equalize. And then what's left here, there's a little bit of water that ends up getting reused. Right here is a drawing of a penguin's foot. How the penguin's foot uses countercurrent exchange to keep the foot just above the level of freezing. So how it does this is the warm blood flows down, it warms the foot, and as it goes back up, the cooled blood will pull heat from the warm blood going into the foot, and it warms up on its way up. So whenever it goes back to the rest of the body doesn't lose that body heat. For this one, I lost the picture for it, so I'll have to go off the computer screen. So pretty much what's happening here is there is cold water. This is a heat exchanger that's working with countercurrent. So you have cold water that's flowing from left to right, and then the hot water is being filled in a tube that surrounds the cold water tube, and it's going from right to left. So what's going to happen is the cold water enters and it gets warmed up as it's going across the membrane, going through that pipe, and it'll be warm by the time it leaves. The hot water is coming in and it starts out hot, and by the time it gets to the other side, it's cold. So here's another example. Cold water goes through, gets hot water goes back the other way, and it maximizes the amount of energy that's being used right here to warm the water, where you would only get 50% if you were going with concurrent exchange, meaning all the water is flowing in the same direction. The last one here is for a zip type gas centrifuge. This is what they use to enrich uranium in order to use it for either weapons purposes or for making nuclear power. It's pretty much what happens is this thing is spinning really, really fast, and the water in the system flows up. Well, it gets warmed here at the bottom, goes up, and it cools up at the top. As it's cooling, it starts to warm up again, and the uranium-235, being lighter, will stay towards the center of this centrifuge, and the 238 will stay towards the outside, still suspended within the water. And those are my 4 examples for concurrent exchange.